Um, we're going to make an adjustment to the schedule. the we were looking at the schedule the other day. Well, I was looking at the schedule yesterday, and I really would like to get. Okay, so we have a unit test, a CMS assessment on Wednesday. That's per your calendar. We have a CMS assessment on Wednesday. So today we have difference of squares and factoring. Tomorrow we do multi-step practice. Wednesday we have a CMS assessment. Then the way that the schedule was written is that we had 2 days back-to-back of extension days. That would put the review due Monday, but then 7th and 8th graders have STAR testing next week. 7th graders have your STAR writing test on Tuesday. 8th graders, you have your mock algebra EOC on Tuesday, and then your 8th grade reading test on Wednesday, which would mean we do a review and then we wouldn't be able to test for a couple days, which I didn't really like that idea at all. So what I'm going to do instead is on after the CMS assessment on Wednesday, Thursday will be extension day. It's just you'll have 2 pages of extension. So instead of doing day 1 and then day 2 the next day, we're doing day 1 and 2 both the same day. You'll do day 1 like it's classwork, check it against the answer key, then you'll do day 2 like it's homework and be done. Then on Friday, your review is going to be due. You're going to get your review today. But that gives you Monday night, Tuesday night, Wednesday night, and Thursday night to complete the review. On Friday, we'll go over that review, answer any questions that we have, and then you'll test on Monday after the weekend. That way, Unit 8 is done. That way, Unit 8 is done. Y'all go off and do your STAR, whatever it is, and then you'll come back after all the STAR nonsense, and we will jump into Unit 9, which is the second to the last unit of Algebra 1. Okay? Any questions on that? Okay. So let's get into today first, and then today is not a terribly complicated day, but what that means is after today, so you have homework tonight, but it's a 1-pager. It's a really short homework. And then when you get done, you can either jump on the multi-step practice, which is a tomorrow classwork thing. You can get a head start on that because you know how to do it all. Or you can get a head start on your review. Either one. Okay? Good to go? All right. So the quadratic equation below is written in vertex form. By the way, really quickly, let's do a quick refresher before we turn this into standard form. Someone tell me about the 1, 2, 3, 4 transformations that you can see off of this, the vertex form of this quadratic. Someone give me one. Joey. It is a shift left 1. That's one of them. Riley? It is a shift down 7. That's the second one. There are 2 more. Avery? It's a vertical stretch with a scale factor of 2, right? Because the multiplication is happening outside the parentheses. Outside is an output, which is y, which means vertical, and it is indeed a vertical stretch with a scale factor of 2. There's one more that you can describe as a transformation. Yes, ma'am. It can't be a vertical stretch and a horizontal compression. See the negative sign? What kind of a transformation is the negative sign? It's a reflection. It's outside the parentheses, so it's vertical. If it's a vertical reflection, it's a reflection across what? It's a reflection across the x-axis. Do not forget that. So 1, 2, 3, 4 transformations. Do not forget that stuff. Got it? Okay, so now we're going to turn it into standard form. We've got to turn this thing into standard form. PEMDAS requires that we do what first? Parentheses. Can you do x plus 1? No. So we have to skip from parentheses to the next one, which is exponents. What is being raised to the second power? X plus 1. So what we really have is x plus 1 times x plus 1. X plus 1 squared. Now you can do this. This is where you can FOIL or box it or double distribute. I'm going to FOIL it real quick. First two is x squared plus 1x plus 1x plus 1, which is x squared plus 2x plus 1. I have FOILed the x plus 1 squared, which means that now I have negative 2 times x squared plus 2x plus 1 minus 7. What must happen next? I have to distribute the negative 2. It's multiplication time. So what I end up with is negative 2x squared minus 4x minus 2 minus 7. Right? I just distributed. And what's my last thing I should do? Like terms, right there and right there, which means at the end of it all, it's negative 2x squared minus 4x minus 9. What can you tell me about this parabola? What can you tell me about this parabola from a description standpoint? Okay, take a shot. It is narrow. It's more narrow than the parent function. Yes, ma'am. It opens down, which, by the way, if you think about it, if it was a vertical stretch, what would that make it become? If you take a parabola and you stretch it vertically, what does it become? It becomes more narrow. If you reflect it across the x-axis, it faces down. Exactly right. Avery? Has a y-intercept of negative 9, and the very last thing that you know is what, Riley? The axis of symmetry is not the y-axis. The vertex is no longer on the y-axis because it has a b value. Now, if I said find the vertex of this parabola, what's the fastest, easiest way to find the vertex of a parabola? Plug it into y equals, and what are we looking for? We're looking for symmetry on our table, right? If we do not see symmetry on our table, what do we need to do? Vertex formula, right? Negative b over 2 times a. Remember, it's on your formula sheet under axis of symmetry at the very bottom. But that is the vertex formula. Negative b over 2 times a, go to second window, plug it in, find the y, you're good to go. By the way, if it's facing down, how would we describe the range? Y is what? Less than or equal to whatever the y value of the vertex is. The axis of symmetry is x equals the x value of the vertex. All those things that we did in Unit 7, dust them off. I know it's been like 2 weeks, and in a teenager's life, that's like an eternity, but you still need to know how to do all those things. Good to go? All right, so today we're going to learn a couple of things. We're going to learn about something called the difference of squares. Difference of squares is actually kind of a cool little trick on how to factor without having to factor. Now, here's the rule. If you have, here, hold the screen shake. Here's the way it works. If you're looking at a quadratic, by the way, how do I know that's a quadratic? Because it has x squared. Very good. If I'm looking at a quadratic that only has 2 terms, an a term and a c term, has 2 terms, and both of them are perfect squares. What do I mean when I say it's a perfect square, Avery? Yeah, what it basically means when I say it's a perfect square, it means there's some number that exists when multiplied times itself would get you the number. Is 100 a perfect square? It is, because 10 times 10 is 100. Is 9x squared a perfect square? What times itself gets you 9x squared? 3x. 3x times 3x gets you 9x squared. Is 25x to the 4th a perfect square? How is 25x to the 4th a perfect square? 5x squared times 5x squared would get you 25x to the 4th. 36y to the 6th. 36y to the 6th. Is that a perfect square? Is the number a perfect square? It is, because 6 times 6. Y to the what times itself gets you y to the 6th, Avery? Y to the 3rd. So it is a perfect square, which basically means that any variable with an exponent that is even, very good, that is even is a perfect square. So here's the rule. If you have two perfect squares and a subtraction sign, which is critically important. If you have two perfect squares and a subtraction sign, here's what you're going to do. You're going to draw two parentheses sets. So you're going to go parenthesis, 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 parenthesis. You're going to make one addition and one subtraction. That's very important. What's the square root of 9x squared? What's the square root of 100? That's it. You're done. Those are the factors. Works every time. Works every time. By the way, I'll show you why it works. 3x times 3x is 9x squared. Let's FOIL it. What's 3x times negative 10? Minus 30x, right? What is positive 10x times 3x? Positive 30x. And then the last two? Negative 100. What happens here? They go away. Because one is addition and one is subtraction, you're basically setting it up so that the b terms cancel. But we don't want to do all that. We just want the trick. So watch the trick. 4x squared minus 81. Is 4x squared a perfect square? Is 81 a perfect square? Is subtraction at play? Yes, so here we go. Watch. Parenthesis, 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 plus, minus. What's the square root of 4x squared? 2x goes in the first places, and 9. You're done. It's a great trick. It's wonderful. You know why it's wonderful? You don't have to work. You just have to know the math. Is this a perfect square? Is a squared a perfect square? Is 9b squared. Now, the way you check it is you think number and exponents. Is 9 a perfect square? Is b squared a perfect square? Yes, so we know that they're both perfect squares, and you have subtraction. So here we go. Parenthesis, 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 addition, subtraction. By the way, you can do subtraction then addition if you prefer subtraction. I don't care. What's the first term? A. Second term? 3b. And you're done. I know. Next one, perfect square? Perfect square? Okay, now they need to stay in that order. So remember, it's addition, subtraction. What's the square root of 64? Very good. 8 and 8. And x to the 6th? X to the 3rd. And you're done. Now, on number 4, is the first one a perfect square? Is the second one a perfect square? Not technically. 1 is absolutely a perfect square. 1 times 1. Okay? But that is a problem. The minute you have addition, it is called prime. What prime means is what? There are no factors other than 1 in itself. You actually cannot factor perfect squares with an addition sign in the middle. It's impossible. You could find none, no parentheses, guys, that could ever get you that one. It's impossible. You know why? Because they don't cancel out. It's gone, and you have no way of canceling it. You're thinking two subtraction signs, right? Watch. X minus 1, x minus 1, right? That's x squared minus 1x minus 1x plus 1. Do these cancel? Nope, it becomes minus 2x. So there's no way to do it when there's addition. So you do 5 for me and 6, please. 5 and 6. Remember, follow the note sheet. if you're still not sure. Mamie, what did you get from 5? Go ahead. Uh-huh. AB plus 1 and? Very good. AB plus 1, AB minus 1. AB plus 1, AB minus 1. By the way, could she have said AB minus 1, AB plus 1? Absolutely. What are these things called? They're called the factors. Make certain you understand what it is that we're doing. We're finding numbers. What are factors, basically, guys? Factors are simply numbers that when multiplied get you another number, right? If we multiply this out, what would we get? We would get this, right? That's why they're factors. Grady, what did you get for 6?
11 plus 5y. 11 minus 5y.
Perfect. 11 plus 5y, 11 minus 5y. Any questions on that? Watch your silly mistakes. Make sure you're going one chunk at a time. Is number 7 an eligible difference of squares problem? How do we know it's an eligible difference of squares problem? Like, what are we doing in our heads from like a checklist to make sure it's a perfect square? Each term is a perfect square. What should we do? Come on, someone who hasn't answered. How do we know the first term is a perfect square? How do we know this is a perfect square? Okay. If the exponents are even and the coefficient is a perfect square, right? If the exponents are even and it's perfect square. And the same thing on the second one, right? So here we go. We do the parentheses, parentheses, addition, subtraction. What is the square root of 4a to the 4th, b to the 10th? Oh, y'all's doesn't? Ooh, that's no bueno. Okay, so y'all's just has this? Okay, so we'll... Oh. Oh. Well, then let's get rid of that. Y'all's has this? Okay, cool. So what is the square root of a to the 4th, b to the 10th? B to the 5th. A squared b to the 5th. And this would be a squared b to the 5th. Also, what's the square root of 9c 6th? 3c to the 3rd. Get it? Yeah. 8. Very good. Prime, because it is not the difference of two perfect squares, it is the sum of two perfect squares, and that is no bueno. 9, y minus x. I actually wrote plus x. Y plus x. Ooh, that was pretty skilled right there. Right? Okay, one other quick thing, and then we'll get going. Before you factor anything, the first thing I want you to do, Avery, is find the GCF. I'm going to start banning your phone. Your face is glowing. It's difficult to hide. The first thing I want you to look for in any quadratic is if there is a GCF you can pull out. Let me give you a quick example. If, okay, if you have 9x squared plus 63x plus 90, and I said I want you to factor this. I want you to factor this. I do not want you to instantly do 90 times 9 and find the factors of 810 so that you're going something times something equals 810 and something plus something equals 63. Do not do that. Now you can, and you'll still get the right answer, but it may take you a long time. Instead, is there a factor that goes into all three of those numbers? What is it, Madison? 9 does. And if you pull 9 out, it becomes x squared plus 7x plus 10. What you can now do is just factor this dude. What you can now is just factor this guy. Which, when you do, by the way, you find out it's x plus 5, x plus 2. Now, this is not your answer when I say factor it, because what are we missing? We're missing that 9 that goes out front. So we put it there, and you are now done. Always look first for the GCF. The GCF makes it easier because it makes the numbers smaller, right? So let's try this. 2x squared minus 32. Is there a GCF? So number that goes into both. What is it? 2. So if we take 2 out, what is it left with? Ooh, x squared minus 16. What did we learn about x squared minus 16? They're both perfect squares, and it's subtraction. It's the difference of squares. So 2x plus 4, x minus 4, and you are done. Much easier. Number 2, is there a GCF? I'll show you. Really? Same number doesn't go into 9 and 81? Pretty sure 9 does. Hold. So I'm going to pull out the GCF, and I get a squared minus 9b squared. Is that still the difference of two perfect squares? Is a squared a perfect square? It's 9b squared. So what we're left with is 9a plus 3b, a minus 3b. Now Madison was going, yeah, but why would you do that? Because they were already perfect squares, right? Agreed? These are still already perfect squares. So if we do just that, what do we get when we do perfect squares here? 3a Now here's the problem. This can still be simplified because see how they still share 3? In the first one, you can take 3 out and it's a plus 3b. And in the second one, you can take 3 out and it's a minus 3b. And 3 times 3 is, yeah. What I'm getting at, you won't catch it. If you don't do it at the beginning, you won't catch it all. Or you're making yourself a lot harder work. Always look for the GCF first. Try number 3. And when you factor number 3, you must use the box method. Huh? Okay. Is there a greatest common factor for that? What is the greatest common factor of these 3 terms? 2 what? So factor it out. You take 2x out, see what's left. That's what I get. All I did is take 2x out of all 3 terms and simplify it. Now, inside the parentheses, I have this, right? I have 3x squared plus 4x minus 15. There's no more GCF, and I have to factor it. So what's the first step in factoring? What's the first step in factoring? A times C. Because whatever A times C is has to be this guy, and B has to be this guy. So this is 4. A times C is negative 45. So I'm looking for factors of 45 that when added together get me positive 4, and when multiplied get me negative 45. So I use my little trick. 2, 3, 15, 4, 5, and 9. 5 and 9 will do. Which one gets the negative between 5 and 9? 5 does, because when you add them, negative 5 times 9 equals this, and negative 5 plus 9 gets me the positive 4 I'm looking for. As you can see, guys, the math gets busy. You have to know what you're doing. If we use the box method, we put negative 5x here, we put positive 9x here. Top left is our 3x squared. Bottom right is our minus 15. And now we start to do our GCF. We start here. That's 3x times x times negative 5, and positive 3, which means my factors are x plus 3, 3x minus 5. Hey, thank you. I cannot forget this guy. 2x goes out front, and that is your answer. The math gets complicated. You have to be organized and neat and stay in touch with everything as you go all the way through it. Let's do one more, and then we'll get rolling on your classwork. Is there a GCF between 12, 39, and 9? What is it? 3. 3 goes into all. So I pull 3 out, which gives me 4x squared minus 13x plus 3. Right? A times C is 12. So something times something has to equal 12, and something plus something has to equal negative 13. What do we think they are? Negative 1 and negative 12. So it's negative 1 and negative 12 and negative 1 and negative 12, which means it's negative 1x and negative 12x. I don't know why I did that, but I did. It's like a shepherd's hook. It does. Yes. At the manger. So I have negative 1x and negative 12x. It says use grouping. Do you remember what grouping is? Grouping is where we replace this with these. So we write 4x squared minus 1x minus 12x plus 3. Very good. You cut it right in half. The GCF of these two guys is x, and that's 4x minus 1. Then we put 4x minus 1 over here, which makes this minus 3. So my factors are x minus 3, 4x minus 1, and we don't forget the 3. Very good. The 3 has to come back at the very end. Those are the factors. It's basically what we did Thursday and Friday, except it's kind of on a little bit of steroidal stuff. HGH. HMH. Human math hormone. Ooh, that would be so cool if that was that. Not that that would be cool. That's steroids. Okay, so here's what we got. You got classwork and homework. Get on your classwork. Do a few. Man. Okay, it's one page of difference of squares. I would do a couple from each section at least, and then check it against your work. Then I would jump into your homework, which is on the desk next to mine. When you pick up your homework, also pick up your review. That review is due on Friday. Good to go? All right.